Hello everyone. Today we have a special presentation on mastering data organization, a deep dive into partitioning in PostgreSQL, featuring the expertise of Mohammad Zaid Patel. So over the next few minutes, Zaid Patel will guide us through partitioning in PostgreSQL, offering valuable insights. Before we begin, make sure to hit the like button, share your queries and thoughts in the comments, and subscribe for more content like this.
Hey folks, good morning. My name is Mohammad Zaid Patel. In today's session, we'll be talking about data organization in PostgreSQL, focusing on table partitioning. So that's me. I've been part of the MyDBOps team for the past 2 years. I work as a database consultant in the PostgreSQL team, quite experienced in the PostgreSQL and the other related database technologies. I've been contributing to the community as an active blogger. I've written a couple of blogs on PostgreSQL. And I'm also a tech speaker. I've spoken at my webinar before. So apart from being a database guy, I like cricket, music, and comedy. Yeah, some briefs about us. We are a database management and a consultancy provider, founded in the year 2016 as a two-member team. We have grown to 100 plus members, and over the years, we have served to 800 plus of happy customers in huge variety of areas like fintech, logistics, e-commerce, healthcare, quick commerce, and much more. We are proud AWS partners, PCI, and a ISO certified organization. We basically offer two types of services. One is the consulting, where we provide expert consultancy for our customers for their project duration or their requirement. The second one is the managed services, where we offer 24 into 7 database monitoring, remote DBS support, database tuning solutions, and much more. So coming to the agenda of this session, we will be discussing why we need data organization, what are some of the advantages of data organizations, techniques used for data organization, table partitioning in PostgreSQL, what are the techniques for that. We'll have a short demo for table partitioning using the PG Partman extension. We'll discuss some limitations of table partitioning, and at the end, we'll discuss some best practices for table partitioning. So let's begin. Uh, yeah. So as we all know, the primary function of a database is to store and retrieve the data. We all use our databases to store loads and loads of data, but most often times than not, we do not think about organize the data that is being put inside. We treat our database as a black box where the data goes in and data comes out, not knowing what is going on behind the scenes. And like with time our black box start getting loaded with all kinds of data and becomes slow, and certainly it does not function as we need it to. Therefore it is very important to look inside our database and to organize it. So organization of data is very essential at the database perspective. It's essential for several reasons, as it plays a very crucial role in the efficiency, integrity, and overall usability of the information. A database would be much more efficient and will perform in an optimal way when the data is organized rather than unorganized. So what are some of the advantages of organizing data? So the first one is better data retrieval. With well-organized data, it allows us for faster and more efficient retrieval of information, as well as we get the database engine with organized data generates more efficient query plans for the queries, which again improves our query performance. Then we with the organized data helps us maintain the data integrity by reducing the inconsistency in data. For example, properly defined relationship constraints and normalization prevents database anomalies, which again ensures that data is accurately reflecting the real world entities. Then with organized data, we get effective storage space requirements by eliminating the data redundancy, and optimized storage then leads to better resource utilization, which also reduces the overall hardware and infrastructure cost. A well-organized database is always easier to maintain and update. Whatever changes to the database structure or the data can be handled more efficiently without compromising the data integrity. Then, well-organized database, when the database is organized, it facilitates ease in the database scalability by allowing the system to adapt to increased data volumes. And finally, we can say it is the process of data analysis and reporting tasks. So let's look into some data organization techniques that we follow. So the first and the basic one is index creation. Index creation is basically at the back end creating a data structure that allows quick access to the table rows. As we all know that indexes have the pointers to locate the table data rows. It improves the data organization and helps us to increase the retrieval speed. That uh, mm, again improves our query performances. Some type of indexes generally used are B-tree, GIN, hash indexes, etc. Then we have data archival, which in general means the process of moving the old data to a different location out of the current working set of the data. Archival cleans up unwanted data from the database that results in optimal usage of the storage. It also helps in data management over time. Then we have the scheme. Then we have the having database schemas. A schema basically is a namespace that can have its own collection of the database objects. Creating multiple schemas provides us the way to logically group the database objects within a database. We can have multiple schemas, which each schema having its own set of objects, like for production, for testing, backups, etc. Another technique we use is functional naming of the database objects. Say having functional names for the database objects like tables, indexes, views, etc. By using practices like adding a prefix or a suffix helps us in organizing the data within the database. It again becomes very easy to understand the database structure and work with it more efficiently. Then we have a relationships among the DB objects. Having relationship among tables avoids creation of orphan rows that in the database do not have any reference. This is again very important to maintain the consistency of the data across the tables. Like in case of where data dilution is happening in the child table and but the record is still being used by the parent, it the DB engines like cancels out the deletion and it throws a error. So we with this we also get efficient query executions that involve that involve multiple tables like the join operation. So now one of the most important data organization technique that we will be discussing is the table partitioning. So table partitioning is a method that involves dividing a large table into smaller, more manageable pieces that are called partitions or child tables. Table partitioning improves the performance of the database by improving the query performance, the data management in the table, and other maintenance tasks like data archival and etc. So let us dive more in the table partitioning in PostgreSQL. So as I said, table partitioning in the backend is a database design technique that involves dividing large table into smaller and more manageable segments called the partitions that we can say as child tables. So here we can see an example of a normal DB table and a partition table. The normal table acts as a whole logical unit that have its own rows and columns, and any change to the table like data insertion, data deletion, or archival need to be performed over the table as one unit. Whereas for a partition table, we can see that the table is divided into multiple child tables. Here the partition, here in this example we can see the table is partitioned based on list partition that we will look into further. So the partitioning here has created multiple units of storage inside one parent table. Now, in case of any changes like data insertion or a reading of the data at the user level, will be same. The process of the reading will be same as we do in the normal table, but in the at the back end, the database treats each child table as a separate unit. So the database, for example, in case of a data insertion, the database will insert the data based on the partition condition. So in case we want to, in case of data, reading the data, if you want to read the players of the club RCB, then we'll use the same SQL query that we use in the normal table, but in the backend, the PostgreSQL will only pick the entries that have the partition key as given. In this case, the RCB. So, yep. In the partition table, the partition key is the main thing that determines how the data will be distributed across the partitions. We'll see the types of distribution in the upcoming slides. The partition of a table results in efficient data management, especially for the database operations like data insertions, updates, deletes, archival, etc. So it also enhances the query performance by allowing the data to selectively scan only the relevant partitions rather than going for the entire table. So as we saw in the previous case, when we give the partition condition as the any one cricket club, it will only say the database will only read from that particular child table and not the entire parent table. So partitioning, especially based on the range partitioning, that also eases the process of data archival, as we can simply discard the old partitions that are no longer required. Like we can whether store it in different schemas as backups, or we can just drop them in case they are not needed. So that yeah. So we can see like what are the types of table partitioning in PostgreSQL. So the PostgreSQL basically supports three types of partitioning. For the first one is the range partitioning. A range partitioning is where a table gets divided into partitions based on ranges of values in the chosen partition key column, which is basically a timestamp or a date column, as you can see in here. So in this partitioning, each partition represents the date from a specific time period, such as it can be days, weeks, months, or years. So this is a syntax to create the child table based on range partitioning, where we are defining the range of dates for this particular child table to have the record from uh, 1st of Jan to 1st of Feb for 2022 to 2023. So all the data will be having all the data between this time range will be stored in the one particular child table. So here we can see a example of range-based partition table where based on the dates of in this case based on the date of creation column, the data is being segregated in the parent table. Then we have the list-based partition, where a table is divided into partitions based on specific values in the chosen key column. Like rows with values falling within specific ranges of these key are grouped into individual partition. So here in the syntax for creating the child table partition for the list base, where we can see we are using a range. We are using a list object, which in this city is a in this case is a city. So here's the example. Here the data is distributed based on the column city. So that is a list based column, and the data is segregated based on that particular list. All the data having the same list column, in this case having the same city, comes under one particular child table. And the last type of partitioning in PostgreSQL is the hash-based partitioning. So this technique divides a table into partitions or child tables based on the hash value of the chosen partition key. So this technique, compared to the other two, this one uniformly divides the data in the entire table. In such type of partition, the partition key, for example, we have a partition key id. The column, this partition technique will generate the hash value of that particular column, for which then a modulus will be taken, and the remainder that we get after division is used to group the partitions. So here we can see the example for the syntax that we are creating. We are using the modulus 3 and remainder 0. So the hash of the id column will be divided by 3, and what based on whatever the remainder, if we get the remainder as 1, then that particular row will be stored in the one child table. Based on the remainders, we can see how the data is segregated in this in a parent table. So these were some of the types of partitioning that PostgreSQL supports. So let's see what are the techniques of the PostgreSQL partitioning. So primarily, we have two types of partitioning techniques. One is the manual one. So the manual one, like where we create the parent table and the child tables manually using the SQL commands. So in this scenario, in the scenario of manual partition creation, like we need all right from the creation of the tables, the dropping, archiving, everything needs to be taken care of manually. Following is a example for the syntax. Here we are creating a parent table that is partitioned based on range. On the partition key is date column. So notice that the primary key of the table is having both the ID and the date column. So this is a particular use, like restriction, that we need to have the partition key as the part of our primary key. And for manual partitioning creation, so this is the syntax we use to create a child table, where we define the child table as a partition of the parent table with the range of values that we need it. Now the second technique that is used is partitioning using the pgpartman extension. So pgpartman is an extension designed to create and manage partition tables. The creation and managing of the child tables is fully managed by the extension itself. The extension includes a background worker which helps in streamlining the process of maintenance, whether it be creating of the new partitions, dropping of the old partitions, or moving it to the backup. Everything is taken care by the background worker itself. So yeah, for we also get other functionalities in using the pgpartman, like like optional retention policies, where we can either retain the child tables inside the database, or we can drop those. And for use so be, when we using the pgpartman extension, we get a maintenance functions that take cares of the partition management on timely basis. We either needed to schedule it on a linux level cron or a database level cron by using tools like pgcron. So that will trigger the function based on our defined time, and it will take care of the partition creation, whether based on the condition, based on the values that we have given. In case new partitions need to be created, it will create it automatically. So to use the extension, we need to create the extension in the database that we are using. Here's the example for the syntax of for creating a partition table using pgpartment. Creating the here, right, the creating parent table is exactly similar that in to that of the manual partitioning technique, but for the child table, here we can see we are using a function. This called partment.createParent, which comes with the pgpartment extension, which automatically creates the child tables for us by using the options that we provide for the parent table name, the control method, which is again the primary key, the in partition interval, how frequently we would need to create new partitions, we can define it. Then we can give a partition pre-make. It will this option will help to create uh, to create the partitions in future, and in case we are having the data older data that we need to store, it will create a partition for those as well. So we'll be having a small demo for the table partition creation. So here I am at my terminal. So here we do not have the pgpartment extension created. So what I'll do, I'll create a new schema for that, for apartment. Then using this schema, I will be creating the extension, create extension pgpartment with the schema. So when I list the extension, we can see pgpartment is installed for this particular database. So using this apartment extension, we will be able to create the partition tables, and we will be able to manage the tables as well. So first we'll look an example for how we can create a manual partition. So here I've made the commands for run. So here I have created a partition table manually. So if we can check the structure of this table, so we have number of partitions currently 0 because we haven't created any child tables, and we can see the primary key is having the ID as well as the created table, that is our partition key. So we will create the child tables for this table. Okay, so we have created some 4 child tables. Can list to check the structure, we can check the structure of the parent table. Now we can see the child tables are attached to the parent table itself, and whatever data that we insert into this table will be like based on the condition, it will be segregated among the child tables. For example, let us say insert some data over here. So as we can see, we have inserted the data based on the created date, and the date is different for all the 4 records. So based on the date that we have given, the table will be the data in the table will be segregated in that way. For example, if we can check the record in this table, then we can see the user A that we entered, it has been accumulated in this particular which has the particular created date. It has been stored in the particular child table. So we are in that same manner, all the rows that are having different created dates will be stored in the different child tables. So now we can have a look for an example for a partition table that is created using the pgpartment. So for that, I'll create another parent table. The parent table creation is always manual. So but for the child table creation, we use the extension. So here I have created a parent table which is having the structure like this. Currently, we can see no number of child tables are present. So we'll use the apartment.create parent function to create the child tables for this. So here I have taken options like we need to define the parent table. The control is nothing but the partition key that we need to that we have created the parent table with. The interval is for how frequently we want the new table partitions to be created. Then the premix is 10. What it will do, it will create 10 partitions for the future and 10 partitions that for the earlier days. So we can see we have so currently from the 21st we have 10 tables in the future past and 10 tables in the future. So what we can do is in case the now the working is similar for these partition tables as well. Whenever we enter the data based on the particular condition, for example, we are entering the data where created date is 14th of December, then that particular data will be stored in this particular child table. So now we can look at the how we can use the PG Partman extension for for the retentions for whether it be for backup or purging the records. So currently we have this setting in PG Partman called the part config. I'll show you. So this has the data of the table that we have created currently, the table one is having the partition interval of 1 day. Here the automatic maintenance is on, and the infinite time partitions we need to set it to true in order to create any new future partitions. Currently we can see the retention is empty, the retention schema is empty, retention keep table is true and retention keep index is true. What it will do is in case we set a particular retention period and a retention schema, then during the time of maintenance whatever child tables that are older than this retention will be moved to the schema that we define. Let us give an example over here. So here I am updating the config. I'm setting the retention as 3 days and the retention schema as backup. I'll let the retention keep table as true. What it will do, any child table that is older than 3 days, it will be moved to the backup schema. So first we would need to create a schema for that. Yep. So now we can give this the details and the details are updated. So now we need to call the partman run maintenance function. This is the function that will when triggered it will take care of the maintenance of whatever actions are required based on the part config setting. So now we have called the function and now if when we check the structure of the parent table, we can see only we are only having retention of 3 days. All the partitions that are older than 3 have moved to the backup. Let us see it. You can see all the older tables are present in the backup schema. So we can also completely drop the child tables. For that we'll create another example. Here we have created another table with the same structure. I will create the child tables for that as well. And when we check the structure of this parent table, we can see that's it. This is having again 10 rows, 10 child tables in the past and 10 in the future. Now when I update the part config for this particular table and set the retention as only 2, and here as you can see I'm using the retention keep table as false, which will completely drop the child table from the parent table. It won't store it in any schemas. So I've updated the part config for this table. I will call the maintenance function again. Now when we check the structure of this table, we can see the older child tables that are older than one day have dropped from the parent table, and that tables are not in the part of backup schema as well. I'll show it to you. Here you can see we do not have any older child tables that are dropped. Yeah, so now let's take a look at some of the limitations of PostgreSQL table partitioning. So table partitioning is only useful when we query the data using the right partition key. We would need uh, we would need regular supervision when using the extensions like pgpartment for partition management. So because in case the partition creation gets failed due to any error, it will not create any future partitions, and all of the data will be moved to a default table partition that does not have any conditions. Then having partition tables increase the complexity in data migration, especially by using tools like DMS, where in case of a normal table, we set up one DMS to migrate the data from one instance to another. In case of partition table, we would need to start separate services for each of the child tables. So that increases the complexity in the data migration part. Table partitioning is also complex for the tables that are having foreign key relationships with other tables. In case we are converting an existing table to a partition table, then we need to drop all the constraints that table already has. Then we need to recreate the constraints to the new partition tables. So this can also fail if the foreign key records are being used by the database. So that again increases the complexity of the partition tables. Then the child tables that are then like we would need to look into the child tables as well, the when the record is not uh, like uh, in case the failure, we need to check the child tables as well. Then for the child tables that are in case we are using the pgpartment function and we are archiving some of the child tables as backup, so we would need to like constantly regularly have look on that. And because with time those will get accumulated and can increase the storage. So a proper retention policy should be in place when using the table partitioning. And when using the pgpartment extension, as discussed, right, in case of any failure of new child table creation, any data entered to a table will like directly go to the default table irrespective of whatever condition that we provide. So this will require repartitioning of the entire table, as pgpartment will fail for the table. So finally, some best practices that we can keep in mind for table partitioning. So it is very crucial to choose the right partition key, as it needs to be used in the condition of the queries, else the partitioning of the table won't be of any use. And as the queries will scan the entire table if the particular partition key is not being used, rather than scanning just a child table. Then for that, we would need to understand the query patterns that we have in our database, and based on that we can decide what type of partition keys we actually need. So we would need to also regularly monitor and tune the performance of the database by, for example, creating suitable indexes for the partition tables, removing bloat from the tables, which again will improve the performance of the tables. Then we would need to choose appropriate partition methods, like whether we need range based, hash based, or list based partitions based on our specific use case and the behavior that we expect from the tables. Then one thing we would need to keep in mind is limiting the number of partitions, as with increase in number of partitions, the maintenance gets complex. For example, in case we need to create indexes, then we would need to create it to all the child tables one by one, which again becomes a tedious process. So by limiting the number of partitions, the maintenance of the partitions gets easier. Then we would need to implement regular data archiving to remove the old and unwanted partitions to free up the space. And finally, we suggest to need to keep up with the upgraded upgraded PostgreSQL database versions as we get enhancement in the partition performance and other DB improvements as well. So you all can scan these QRs and follow us on LinkedIn to get updates on the latest in the database world, the tech blogs, posts, and much more. You can also subscribe to our YouTube channel and get access to all the my webinars and other tech talks that we have done so far. Feel free to reach us at info@mydbms.com.
A big thank you to Zaid Patel for sharing his knowledge. We are truly grateful for the wealth of information, Zaid. And to our viewers, thank you for being a part of today's presentation. Stay tuned for more exciting presentations and webinars. Check out our social media activities for updates on upcoming webinars, meetups, and additional resources. As we wrap up, don't forget to subscribe to our channel and turn on notifications. Thanks for joining us today, and we look forward to seeing you in our next video.